Amy Sherman from MLive and Michigan's Best, and we continue our podcast series on Michigan sugar, makers of Pioneer Sugar. And today, we're gonna finally learn how this whole process works, from the farm to the factory to your table. And we've got Jason Lowry with us, who is the VP of Operations at Michigan Sugar. Jason, thank you so much for joining us.
Thank you, Amy.
So for my readers and watchers who've been following along, we've been talking about all sorts of different things with Michigan Sugar, everything from the history of the company to human resources and what kind of jobs are available there. But I know everybody's been dying to learn how a sugar beet actually gets turned into this lovely, beautiful white sugar that we use in our delicious baked goods. So Jason, can you walk me through kind of how this works for a lay person who's not in the sugar industry?
Sure, we can do that. Everybody would be very aware of the harvest that we have that starts end of August and typically goes through the middle to late November. But during that time period, in the first part, we're harvesting beets only as much as needed to process in the factories until about the middle of October, towards the end of October, and then we go into what's called full harvest. And during that period, we'll pull all of the remaining beets, put them into large piles that most people have probably seen out around the thumb, and we store those there and bring them into the factory as needed from that point until we're finished in March to April. So that's the harvest process, and that's the piling. From there, once the beet comes into the factory, there's a series of unit operations that are used to convert it into crystalline sugar, as you mentioned. The first is we have to clean the beet, because what's coming in with it, there's going to be dirt, there's going to be tops, there's going to be sandy soil, some rocks, all of that. And so
because
right in the
it's really a
upfront,
natural product. I mean, we should really state that. I mean, this is coming directly out of the ground. And like you said, I think a lot of people they don't even know really what a sugar beet looks like, but it looks like kind of like a regular red beet. It has the big green fluffy top. It's coming right out of the dirt. And then you guys have got to take that, chop the top, clean off all that dirt, so then it's ready to go through the slicers.
Exactly. So the more dirt that you get out up front, the less you have to deal with in your process. So you're getting the impurities out before you get into the process. So we go through an extensive cleaning process. Then we go through the slicers that you referenced. And what will come out of the slicers will look like French fries for the most part.
Okay, wait, let's talk about these slicers, because everybody in your industry talks about these slicers. And I mean, I envision like a million little knives chopping up sugar beets. What do they look like? How do they work?
The majority of them that are used in the industry anymore are called the drum slicer. And so you'll have a 4.5 to 5 foot diameter drum that has hundreds of, or less than 100 actually per, but knives that are inside there with a serration in them. And you change the spacing on it to get the thickness of the cassette, is what's called, that comes out the other side, for maximizing of diffusion. So
when the beets when they come out of that drum chopped, are they a puree? Are they a dice? Are they, you said French fries. So
they look like long French fries.
Okay.
So ideally they would be individual slices, individual French fries. And the reason for that is the more surface area that you have, the faster you can diffuse the sugar out of it. So you're trying to maximize that surface area, yet retain enough of the structure to where it doesn't fall apart and turn into mush like you were referring to.
Oh, okay. I've already learned so much. Okay, so then after we have our little batons of sugar beets, then what happens?
Then it goes to the diffuser, and in all of the plants that we run here, it's a tower diffuser. These diffusers would be somewhere between 6 and 9 meters in diameter, and the diffusion section would be 20 to 22 meters high. We'll feed the cassettes into the bottom, so they're full of sugar, and we feed fresh water into the top, and it's countercurrent diffusion, so as the water goes down, it picks the sugar up, and the pulp coming out the top will have given up the sugar and be turned into the animal feed that we produce.
So at that point, then, you essentially have sugar water?
Juice is what we call it, raw juice.
Okay. Sugar juice sounds kind of yummy.
Yeah. And the juice that comes out there, so it will still have several impurities in it. It will be a light yellow color. It'll have some sand, some dirt, you know, other things that are in it. So from that point on, it's all about processing, purifying, and crystallizing. So the first step in processing is we'll add lime to it, which is calcium hydroxide or calcium oxide. And that lime raises the pH over a short period of time. And as it raises the pH, it attracts those impurities to it. Then we hit it with carbon dioxide, which is called carbonation, and that creates particles, big particles that will then settle out. So through adding the lime and then the CO2, we go from a brownish yellow liquid to a very light colored, almost like champagne colored light liquid that then goes on to further processing.
Okay, so we now have a pretty pure liquid, and now I assume it's time to make the sugar crystals?
Before you do that, you have to evaporate off the water. So
that's true.
Point, the sugar juice is going to be somewhere between 15 and 17% sugar. And in order to make crystals, we have to get it up to 100. So what we'll do is run that through evaporators, a series of evaporators, and these are very big, tall cylindrical vessels that you'll see in the factories. And through that process, we'll drive off all of the water, reclaim the water for reuse, and have a 74% sugar solution then going on to crystallization.
Okay, so you guys reuse, you mentioned that you take the pulp or the leftover sugar beets, you feed that to animals, then you reuse the water. So you guys are really trying to conserve as much energy and products at Michigan Sugar as you possibly can.
Absolutely. It's about cost, but it's also about being a good steward to the environment and the community. And so what we need to do is minimize our impact, and how we do that is through reuse and cleaning up and putting back into the environment.
Well, we all can appreciate that. Okay, so now we're ready to crystallize the sugar. We've got a 74% kind of mixture. What does it look like at that point? Is it still liquid?
I'm sorry?
Is it still liquid at that point?
Yeah, it's thicker liquid. It's not quite molasses consistency, but it's a thicker liquid. It takes bigger pumps to now push it because it resists the flow a bit. But at this point, it would be a darker, almost a brown color, because you've concentrated up those color bodies. And so next what you do is you go through crystallization. And one thing that people think about when they think about crystallization is that we're creating sugar. We're not. All we're doing is separating the sugar that's there from the non-sugars or that color, those color bodies and other foreign materials. And you do that under very controlled conditions over a period of time. And you grow those crystals from an 8 micron size crystal into what you see in the bag.
How do you do that?
Steam. You evaporate off the water and you do it in a controlled fashion over time to where it excludes the impurities and the sugar, the sucrose molecules come together.
How long does that take?
For a white pan, it's typically 2 3/4 of an hour to 3 hours, somewhere in that range.
Oh, so not that long. Okay, I was thinking like days.
No, if you take into account the entire process is much longer. But that crystallization, once you've purified it, got rid of the majority of the impurities, and driven off most of the water, all you have to do is drive off a little additional water, and then and grow the crystals in a controlled fashion. Super saturation.
Now, after you've got the crystals, do you then filter the sugar again to make sure that it is pure and it's all good?
Yeah. So 2 things there. Directly after the pan, you go to a centrifugal, and that centrifugal, think of it like your clothes washer sitting on its side. You'll spin the sugar in there, and any liquid that's remaining will go through the basket out. And so that's how we get very pure. Then we do a wash, then we dry it, then we cool it, then it goes into the bin and into the bag. Wow. But separate to that, I think the thing to be aware of is we actually crystallize that sugar 3 times. So we have white pans, and the product that comes off of that white pan is the white sugar. Then what's left, we crystallize 2 more times just to get as much of the sugar out of it as we can before shipping the molasses.
Oh, interesting. Now, we could have a whole nother show about how to make brown sugar and powdered sugar, right?
Yeah, exactly.
But I do want to spend a little bit of time just talking about the 4 factories that you guys run over in the Thumb region in Bay City, Caro, Crosswell, and Sebewaing. When I heard that these were your original factories that were built in the early 1900s, I was like, what are you telling me? But then I learned that you guys have really upgraded them all, and they're very technologically advanced, but they still are in their old casings. Is that right?
Yes, that's very much correct. The original factories were started at the turn of the last century, so between 1890s and 1900s. And over time, we've expanded them dramatically in terms of what their throughput is. And we've changed out technologies to become much more efficient, much more effective at recovering the sugar. But that being said, these are old facilities. Some of the brickwork, some of the ironwork that you'll see has been around since the early 1900s. And it's a constant renewal that needs to happen on our part through either capital or maintenance. So in any given year, we're putting well in excess of $50 million back into the plants in terms of maintenance dollars to get back up to where we need to be for the next year, or renewing where we're changing out processes, whether it's for higher capacity, higher efficiency, or new environmental regulations.
That's super interesting. Yeah, I can only imagine that to maintain these buildings that'd be a job all in itself, right?
That's absolutely correct.
Now, Jason, how did you get started at Michigan Sugar? Did you wake up when you were like 15 and say, I want to be director of operations at Michigan Sugar?
Actually, I've worked in the industry at other companies for the last 23 years. I've worked in high fructose corn syrup in the Midwest. Then I worked for another beet sugar cooperative in Fargo, North Dakota for about 10 years. And actually, I took a detour down to Australia for 7 years and worked in the cane milling industry.
Cool.
At which point I came back here as the VP of Ops. Cane sugar and beet sugar are very similar, but beet sugar is really my passion. That's why when the offer came to come back to Michigan and work here at a very family-oriented, very community-centric type of a company, it was an easy decision.
Are you from Michigan?
I'm originally from Montana, Northwest Montana.
Ah, a beautiful part of the country. So how does one develop a passion for sugar beets? What is it about them that is so special to you?
Well, my family is originally from eastern Montana, so both my father and two of my uncles worked in a sugar beet factory there. So we have roots all the way back to there. But really for me, as a chemical engineer coming out of college and working in this industry, it's amazing the amount of chemistry and optimization and continual renewal that you can do here. It's continuous problem solving. And I haven't worked in an industry yet that is as integrated energy-wise as this industry is. And to that point, Michigan Sugar is the most energy efficient company making beet sugar in the US.
Wow, that's impressive and very good to hear for a great Michigan company. I love it. Well, Jason Lowry, thank you so much for sharing your story and teaching us how sugar comes from the field to your table. It was so fascinating. I love it. If people want to get more information about Michigan Sugar, you can, of course, go to michigansugar.com. Jason Lowry, the VP of Operations at Michigan Sugar, makers of Pioneer Sugar. Thank you for joining us.
Thank you.
All right, if you want to know more, of course, you can follow our series along right here on Facebook. And of course, if you want to get more information about Michigan Sugar, makers of Pioneer Sugar, you want to go to michigansugar.com.